can do it without a calculator. All right. First with the parent graph, and the parent graph is obviously sitting right on top on your page here. This is the parent graph of 1 over x. I'm going to do p of x for parent, and that's what you're looking at. So what transformations have occurred on the parent graph to get us to g of x? Transformation number 1, Abby?
2 units to the left.
Shift it 2 units to the left. Transformation number 2, Bridget? Down 2. So when we move 2 units to the left, which asymptote moves? The horizontal or the vertical? Right. I mean, they both technically move, but a horizontal line shifted over 2 units is still going to be the same horizontal line, whereas a vertical line shifted over 2 units is going to move locations. So the shifting left 2 brings you here. And the shifting down 2, therefore, is going to move the horizontal asymptote down 2. And all this really does for us is sort of gives us a different origin to work off of. Now our quote-unquote origin is at -2, -2. And then we just kind of throw in a point and follow a similar pattern. The point that we plug in both cases is 1, 1 and -1, -1 relative to the origin. Does that make sense when I say relative to the origin? Okay, those aren't relative to the quote-unquote new origin. I just think that's the easiest way to describe it. You don't need to actually write down what those points are. If you did, it would be -3, -3, and -1, -1. That's simple enough? Okay. This one here is a different parent graph. This is the parent graph of 1 over x squared. If you had to summarize really the difference between the previous parent graph 1 over x and this parent graph 1 over x squared, how would you categorize or explain the difference visually? Olivia? It looks like there's one vertical asymptote as opposed to 2 vertical ones? Because there still is a horizontal asymptote, you see it? What else? Try again. Aiden? It doesn't cross the x-axis. Meaning, well, this one didn't technically cross the x-axis either.
Well, it doesn't have anything beneath the x-axis.
Correct. It's always positive. And I think algebraically we can see why. No matter what we plug in, we're going to square it, and it's going to be 1 over a positive number, which is going to be a positive number. Okay. How about the fact that 1, and I'll do them side by side cleanly. 1 is like this, and 1 is like this. What could you do to this graph? What could you do that would turn it into this one? Go ahead, Joe. Maybe the absolute value. So if you took this function, it would be close, because by taking the absolute value, you're taking any negative piece and it would flip up because it would have to become positive. And that's really kind of the image that I want you to realize, is that this does sort of flip up. The numbers are slightly different because if you plug in -1, -1's a bad option, -2, this one will be -1/2, versus if you plug in -2 here, this one will be 1/4. So those actual values are different, but the look is pretty similar. It's just that this piece that's negative got flipped positive and condensed a little bit, but we can just look past that. So what is also different that I'm going to shed light on is the fact that this one had an asymptote, a vertical asymptote at -2. And that particular factor in the denominator, this is important, this only had a degree of 1. Whereas this factor in the denominator has a degree of 2. It's not going to give us 2 vertical asymptotes. We're still only going to have 1 vertical asymptote at x equals, where's our vertical asymptote going to be? X equals 3. But because that asymptote has an even degree, think about even roots. We bounce, right? Even asymptotes have the same behavior regardless of which side you're coming at it from. So whether you're coming at this vertical asymptote from the right or from the left, they're both going towards positive infinity. Whereas vertical asymptotes that have a degree of 1 have different end behavior depending on which side you're coming at it from. Does that make sense? So it's not, I don't think it's official, correct math language, but I will talk about what's the degree of the asymptote. And if it's an odd degree, that gives you some insight that one side will go towards infinity and the other side will go towards negative infinity or vice versa. If its degree is even, then they're both going to go either to infinity or to negative infinity together. And so that will give you some insight when you're starting to sketch more difficult graphs here. So at any rate, this parent graph gets shifted right 3, which will move our vertical asymptote right 3. And up 2, which will move our horizontal asymptote up 2. And then we're just going to sort of redo that parent graph with a point at 1, 1 relative to the new origin and negative 1, 1 relative to the new origin. And we kind of nestle that in the corner there. Mine look a little bit too much like L's right now. They should be a little more curved than that. Sorry. It's also, these can be pretty difficult to wrap your head around when they're sitting on top of each other because there's just a lot going on. Okie doke. All right. Now, better ones. Ones where they're not straightforward transformations from a parent graph. And we won't use parent graph techniques with this type because our parent graphs have 1 in the numerator, and that's pretty limiting. So we will always start by finding vertical asymptotes, holes, and horizontal asymptotes. That's where we'll start. So first things first, with any function, you should try to factor it and simplify it if that's at all possible. And then if something were to cancel, you'd have to find the hole. Doesn't happen here. Vertical asymptotes are where, Bailey?
-3 and 3.
-3 and 3, so I'll throw those in there. I'm also going to write that down. Horizontal asymptote. These are the degree rules we worked on yesterday. So would this one qualify as small over big, big over small, same over same? John?
Would be
Same over same. So the horizontal asymptote is? Four 4 over 1, coefficients, good. So we can get that on our paper. Okay. Once we have that, x-intercepts and y-intercepts can be helpful. Okay, so x-intercepts, y-intercepts. I don't know which one's easier. We'll do the y-intercept. We'll set x equal to 0. What's the y-intercept going to equal? Andrew, thank you. You guys don't have to raise your hands. Just tell me, please. 0. So we have a y-intercept at 0. So we know the graph has to go through that point. Now, because our y-intercept kind of put us in between our two vertical asymptotes, we can focus in between there for now. So as I approach this next asymptote, this graph's either going to shoot up towards infinity or shoot down towards negative infinity. Okay? Any guesses? What would you guess, Connor? And why would you guess negative infinity?
Because the horizontal asymptote is above that point.
And what's the horizontal asymptote got to do with it? Anybody else have a guess? There's really no way of knowing. Were you thinking negative infinity because you don't want your graph to cross the horizontal asymptote? Okay, but remember that you can cross horizontal asymptotes. Verticals, no, but you can actually cross horizontal asymptotes. All right, well, let's see here. To figure it out, you have to play around with points a little bit. And you don't need exact values. But if you plug in a 2, for example, are you going to get a positive number or a negative number? 2 squared is 4. 4 times 4 is 16. 16 over 2 squared is 4. 4 minus 9 is negative 5. 16 divided by negative 5 is what kind of number? Negative number. So it probably is going towards negative infinity. So send that way. And then as you go the other direction, towards the other vertical asymptote, it may also go towards negative infinity or it might go towards positive infinity. If we plug in negative 2, what happens?
You get a negative number.
Not only a negative number, but the same negative number, right? Because now this kind of sheds some light on the fact that, oh, this function is, starts with an E and ends with Ven. You guys, even, right? If you plug in 2 and you get the same number that you would get when you plug in negative 2, maybe it's a coincidence. Not that can happen coincidentally with a single number, but then that might trigger you to be like, oh, right, this is an even one. Because if I plugged in a negative x, I'm going to get back the same function, which is something to keep in the back of your mind because you got to keep everything now symmetrical to the y-axis. Does that make sense? So bring that back around. Now, this particular asymptote, the asymptote with x equals 3, which would come from this factor, does this asymptote have a degree of 1 or a degree of 2 or a degree of 3 or what does it have a degree of? Just, right, that's technically to the first power. So when you have a degree to the first power, you know that that asymptote is going to have opposite behavior on either side. So this side's shooting towards negative infinity. This side's shooting towards positive infinity. Does that make sense? And then as you go towards infinity, that's what horizontal asymptotes are there for, is to guide that end behavior. So I'm going to come down. I don't really care about specific points. Okay? If it's a multiple choice and some specific points are labeled when you're trying to choose an appropriate graph, you can feel free to try to use those numbers and plug them in. But just on the basic look of it, you should be able to get it right. You shouldn't have to plug in points. And then likewise on the other side, this one also had a degree of 1, right? So if this one goes towards negative infinity coming from the right, then it's going to go towards positive infinity coming from the left. And that horizontal asymptote is going to guide our end behavior as we go towards negative infinity as well. Let's see how we did. 4x squared divided by parentheses x squared minus 9. Zoom 6. That was beautiful. I never did do the y-intercept because if your x-intercept is 0, then your y-intercept has to be 0 also, right? So I didn't have to actually go and do that. Good? Okay, next one. Let's first factor this guy. No holes, because nothing cancels. Vertical asymptotes where, Marissa?
At 0, -1.
Say it again.
0, -1.
Good. So, just by the way, based on this, I know it's not an even function, because my asymptotes would have to be symmetrical too. Horizontal asymptotes. Mitch, what category does this fall into? Small over big, big over small, same over same.
Small over big.
And so the horizontal asymptote is where?
Y equals 0.
Very good. Okay, so let's do y-intercept. Oh. I take back what I said on that one. I said it backwards. I found the y-intercept. I didn't find the x-intercepts. Right? I said x equal to 0, so I actually found the y-intercept. And that was one of the x-intercepts. Anyway, small point. So we'll start with the y-intercepts again. So g of 0 is going to give us what? Nate? Try again. One. Good. So we have a y-intercept at 1. So I'm going to focus in between those two vertical lines right now. As I get closer to -1, this is going to be a little bit tricky because I have to mentally plug in a decimal. And again, I want to reiterate that the value doesn't matter so much as you determining whether or not that's going to be a negative or a positive. Does that make sense? So let's pretend I plug in something like -0.999999999, right? If I plug in something like -0.99999, getting infinitely close to -1, let's say, I'm going to have -2 over -2.9999999. I'll just do 9 repeating, times -0.99999 plus 1 is going to be what? negative 0.9999999 plus 1. Andrew? Is it going to be positive or negative? Let's start there.
Positive.
Positive, barely positive, right? Like 0.000001, right? So again, we don't care about the value. We care about, is this going to be a positive number or a negative number overall? Positive, right? Negative divided by a negative times a positive is going to be a negative over a negative, which is a positive. So, positive infinity. Which makes sense, actually, because think about this. And think about this, because these are thoughts you're going to have on your own at some point here. If you're taking a negative 2, like this is essentially negative 3, right? And the closer this gets to negative 3, the closer this one's going to get to 0. When you take negative 3 and multiply it by a teeny, 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 tiny number, it's going to be a teeny, 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 tiny number, right? And if you leave a numerator a constant and continue to divide it by something smaller and smaller and smaller, the number gets larger and larger and larger, right? 2 divided by 1/10 versus 2 divided by 1/1,000,000th. When you take the whole number 2 and divide it by 1/1,000,000th, it goes in 2 million times. Do you follow? So there's where that humongous number is coming from. Now, if I'm plugging in like 1.99999, let me do that. So we go towards the other asymptote. That'll be negative 2 over 1.99999 minus 2 is going to be barely negative. And 1.9999999 plus 1 is going to be 2.99999, which is essentially 3. So what's happening? Same thing, right? Essentially. A negative over a negative. This number continues to get, the product in the denominator continues to get smaller and smaller. So we're also going to get a positive infinity. So this actually comes back around. Oops. And so it's almost like a parabola in between there. Which isn't always the case. It just happened to happen that way twice in a row just now. Hopefully the next one won't happen that way. Okay. And then degree of asymptote here. The asymptote at 2 had a degree of what? Everybody? 1. And so if it had a degree of 1, then we have got opposite behavior on either side. This one towards positive infinity. This is going to come towards negative infinity. And then my horizontal asymptote is going to guide on behavior. And the same is true for the other side. How are you doing? It's almost like it's kind of symmetrical, but not over the y-axis. In fact, you're not going to have to do this, but your minimum value is probably not your y-intercept, right? It's probably halfway in between your asymptotes. So if I try this one, negative 2 over so see how that's not like perfectly symmetrical to anything? You could find the minimum on a calculator. We won't do that by hand, but the minimum from that stretch is at a half, which is between, is that between negative 1 and 2? No, it's not, is it? I mean, it's between it, but it's not perfectly between it. Oh, yes, it is. Yes, it is. Negative 1 and 2 average to get a half. Oh yeah, it is. It doesn't have to be, but like it usually kind of is. All right, any questions on that? Okay, this last one. Can't simplify, can't factor, so can't simplify. Vertical asymptotes. What are your thoughts, Morgan? There aren't any, right? There's no way the denominator will be 0. So we have no vertical asymptotes. This is new. Horizontal asymptotes. Sarah? Right. There aren't any horizontal ones either. So we're out of asymptotes. X-intercept. We'll set y equal to 0. So that's this whole thing equals 0. When will this equal 0? When x is... What makes a fraction equal 0? When the numerator is 0. And the numerator will be 0 when x is 0, right? So our y-intercept, no, our x-intercept is 0. Our y-intercept, when x is 0, will also be 0. So after doing and looking for 5 features, for vertical asymptotes, holes, horizontal asymptotes, x-intercepts, and y-intercepts, we have a whopping 1 point to work with, which is not good, right? In a case like this, you have no choice but to try like testing values. What's h of 1? What's h of 1? Trista? 1. If I plug in 1, I'm going to get back 1. So 1, 1 is a point. What's h of 2? Take a minute, think about that. Mackenzie, what do you think?
6.4.
6.4 is correct. You don't have a calculator, do you?
No, I did that.
The 2 fifths in your head? Yeah. So you get 32 fifths. 5 goes into 32 6 times with 2 fifths left over. 6 and 2 fifths is 6.4. So 2 and then 1, 2, 3, 4, 5, 6.4. All right, so we get the idea. It's kind of hurrying its way up anyway, right? What if we plug in -1? Abby?
Wouldn't it just be 1?
Right. What realization could you have at this point, Nate? It's even, so it should be symmetrical. So if I plug in -2, I'm also going to get 6.4. And it kind of looks like a parabola. Let's check it out. 2x to the 4th divided by, whoops, x squared plus 1. Good. Is it a parabola verbatim? Maybe. We'll know if we try to simplify that, but the only way to simplify that is by doing long division at the bottom. So, if this long division works out perfectly, we already can see an x to the fourth divided by an x squared is going to be some sort of quadratic, right? If there's no remainder and it truly goes in evenly, then that will be exactly what it was, right? But if there's a remainder, it's slightly off from the asymptote that's going to be called a slant asymptote. So let's do 2x to the fourth divided by x squared plus 1. Is this the same one we did yesterday? No, we did a cubic one yesterday, didn't we? Yes, we did, because it was a linear asymptote yesterday. And this is going to be a quadratic. So x squared times 2x squared. First, so I get 2x to the fourth plus 2x squared. I'm lining everything up properly, doing my subtraction. I get 0x cubed minus 2x squared. And I repeat. 0x squared times what? 0x will give me 0x cubed. Do my subtraction. I'm going to get negative 2x squared plus 0x. I can bring down my 0 if I want. X squared times what gives me negative 2x squared. So that should be a negative 2. Do my subtraction. Gone, gone. 0 minus negative 2 is a remainder of 2. So, our graph is not a perfect parabola. But this parabola is the asymptote that it's following. So I'm going to plug in this parabola next to the original function just so that you can see 2x squared minus 2. Just so that you can see that as we move towards the infinities, the y values of this one and the y values of this one are converging, getting closer together. And you're going to see that best, I think, from the table. So here's your x coordinates and here's your y coordinates. So they're off as we start. But as we increase our x coordinate to 1, they're a little bit closer, right? They're only 1 off. Then they're only 0.4 off from each other. Then they're only 0.2 off. Then they're only 0.118 off. Then they're only 0.07. You get the point, right? So as we move towards infinity, they converge. And as we move towards negative infinity, they converge. And that's what an asymptote does. Guides on behavior. Follow? This is all good stuff, you guys. Your mind blown? This whole world was out here this whole time, and you didn't know it. Pretty good stuff.